Hello everyone. We are going to continue with the previous video of solving numericals based on Ohm's law. Now, this time we are going to take a little bit more difficult questions or a little bit more different questions. Okay, wherein we'll be applying different formulas of the Ohm's law in different ways. I mean, there's only one formula, but we can use it in three different ways. So, what is the formula given by Ohm's law? Sorry, which gives us Ohm's law gives us the formula V is equals to IR, which can be used as R is equals to V by I, and which can be used as I is equals to V by R. So either one of them will be using. Okay, so let's read the first question. The potential difference between the terminals of an electric heater is 60 volts. So V is given as 60 volt, and the current which is drawn is 4 ampere. Now, when the current of the heater will be changed to 120 volt, what is the current flowing? So there is a second voltage. So that is the second part of the question. So in the first part of the question, we have to find the resistance. Okay, the resistance is V by I, which is 60 by 4. So R is 15 ohm. Now in the second case, they are just changing the voltage from 60 to 120. What is going to be same is the resistance, because we have to find the current and nothing about the resistance is mentioned, right? So that is why we found the resistance in the first case. The change in velocity voltage has been mentioned here, but we need to find the current. That's what they're saying. What is the current that will be drawn? So current is equals to V by R, which is a 120 by 15, which is a 8. So 8 ampere current is drawn through the electric heater when the voltage is 120. Okay, next question. When a battery of 12 volt is connected across an unknown resistance, there is a current of 2.5 milliampere. We have to find the value of the resistance. Okay, so voltage is 12, current is 2.5 milliampere, which is 2.5 times 10 raised to minus 3 ampere, which is 2.5 divided by 1000, which can be more precisely written as 25 divided by 10,000. Why? Because I've removed this. Okay, it becomes more easy to divide. That's the simple rule. So I need to find resistance, which is V by I, which will be a 12 divided by 25 divided by 10,000, which will change out to be a 12, 1 lakh 12, 20,000, sorry, divide by 25, which is 4,800 ohms. Now, if you see, the resistance is so big. Why? Because the current is very small, and we know that there is a inverse proportion between the current and the resistance. The more the resistance, the less the current. Correct? So this rule is applicable here. That is why the resistance is so big. Next, an electric heater is connected to a 230 volt main supply. So voltage is 230. The current flowing through the heater is 8 ampere. The first part of the question is telling us to find how much charge is it flowing through the circuit for 1 second. So time is 1 second, right? So the formula for charge will be from the formula for current. So I is equals to Q by T. I is 8 ampere, Q remains Q, and time is 1 second. So 8 coulomb charge is passing through the circuit in 1 second. Okay, the next part of the question, what is the resistance? So resistance is V by R, that will be equal to 230 divided by 8, okay, which will be a 228.75 ampere. Okay, sorry, ohms, not ampere, it's a resistance. Okay, clear? So now we'll be doing a question wherein again there will be application of Ohm's law more than once in the same question. Okay, this one I'm just leaving it for you. I'll just give you the hint. The remaining will be your work. Why I'm going to give you the hint? Because it's 200 milliampere and 4 kilo ohms of resistance. So V is something you need to find. PD, the short form for potential difference, has always been represented as P dot D dot. P for potential, D for difference. Okay. So here current is given to be a 200 milliampere. Again, milli means yes, 10 to the power minus 3 ampere. So that will be 200 divided by 1000, which will give me a 2 by 10 ampere, right? I'm keeping it in a fraction because it's easier to work around. You can you change it into decimal and do it if you're comfortable. Okay. The next is your resistance, which is given as 4 kilo ohm, means 4 multiplied by 1000 ohm. So resistance is 4000. Okay, then you will say voltage is equals to IR, which is 2 by 10 multiplied by 4000, which should be a 800 volt, right? Clear? Okay. Next, a PD of 10 volt. P dot D means potential difference. So potential difference is 10 volt is needed to make a current of 0.02 ampere to flow through the wire. What is the PD needed if we want a current of 250 milliampere to flow through the same wire? So there are two things we need to find here. First is the resistance of the circuit. And then when you change the current, then what is the amount of voltage? So what is not changing or what is constant in this whole situation is the resistance. So first thing that we'll be finding is the resistance. So R is equals to V by I, which is a 10 divided by 0.02, which is actually 1000 divided by 2, which is a 500 ohm. Okay, so my resistance is 500 ohm. So R is a 500 ohm. Now we are changing the current to 250 milliampere. So again it is 250 times 10 raised to minus 3 ampere. Means I can write it as 250 divided by, 1000 ampere, right? So that is equals to 0.25 ampere. Okay. If you want to keep it in fraction, it will be 25 divided by 100. Okay. So now what we need to find? The potential difference. So potential difference is current multiplied by resistance. So current I'm going to keep it in fractions. 25 by 100. Okay. Multiply by resistance, which is 500. So this changes to be a 125 voltage. So what did we do? We found the resistance, which is going to be same for both the same, because the instrument is same, or the circuit is having the same resistance. We are not changing the resistance, but we are changing the amount of current flowing. So in the first case, using the voltage and the current given, I found the resistance. Use the same resistance and the change in current to find the voltage. Okay. Now there's some questions which I've taken. I'll be giving you a hint how to do it. Okay. Now the first question, what is the resistance of the coil which draws a current of 50 ampere, 200 microampere and 120? So first case is 50 ampere, I is 50 ampere and volt is 120. Find your R. Ampere, milliampere means 10 raised to minus 3 has to be multiplied, and micro means 10 raised to minus 6. Okay, so first case your I is 50 multiplied by 10 raised to minus 3. In the second case it is 200 multiplied by 10 raised to minus 6, and you need to find R. Okay, next, an electric iron draws a current of 3.4 ampere from 220 volt supply line. So you have your I, you have your voltage. What current will it draw when the current when it is connected to 110 volt supply? So first case you have to find your resistor, which is not changing. Okay, that is your step 1. 3.4 and 220 volt. Use this and find your resistance. Use the resistance which you found in the first step and the voltage given to find your current change. Am I clear? The first step, you'll find the resistance given. Use that resistance and the voltage change to find the current. Clear? Next, the same electric room heater with current 2.4 ampere and 120 volt. Find the current which is now being drawn if the voltage changes to 240. Again, the first step is use V and I to find your resistance. Okay. Then you will use this resistance in the second step and the voltage given to find your current. So two things you need to find: resistance, and then the situation changes to find the current. Am I clear? Okay. The fourth one, again, the TV draws a current of 5 ampere from 240 volt. What current will the TV draw when there is 100 volt? The same scenario. I have my I have my V. So first step is I'll find the resistance of the TV. The resistance of the TV is not changing, but the supply voltage is changing. So when the voltage is changing, I need to find the current. So now what is same? Resistance is same. Use the resistance that you found in the first step, apply it here and find the current flow. Clear? Same with the last one. The potential difference between the terminals of an electric heater is 60 volt when it is drawing a current of 4 ampere. So again, the voltage is given, the current is given. You need to find your resistance, which is not going to change. It's going to be same even if I'm changing the voltage to 120. Okay, so in the second scenario, you're going to use the resistance that you found in the first step, use the voltage change and find your current. Am I clear? I've taken all the questions same type, similar type, where you have to first step, you have to find the resistance. And then in the second step, use this resistance and use the voltage given or the change in the current given and find the respective voltage or potential. Hope I'm clear, right? This is how we use Ohm's law in different various ways. Thank you.